Alright guys, welcome to our channel Code with Sunny, and today I am going to discuss the problem pair of songs with total durations divisible by 60. The second problem of the month of January 2022. It is the you are going to have a daily LeetCode challenge problem, and today we are going to discuss this medium type problem. Okay, so the prerequisite required to solve this problem is like hash map, or you are you need to be aware about the certain type of problems. If you are done, if you already done that problem, then it is awesome, and if you are not done, then you are going to learn something new in this video. Okay, so let us begin. We have been given a list of songs where the ith song has a duration of some time of 5 seconds. Okay, and we need to return the total number of pair of songs for which their total duration in seconds is divisible by 60. So in mathematical terms, what has been denoted over here is like we have been given some array a1, a2, a3, a4, a5, let's say, and these are some values, and we need to return the total number of pairs I comma j, where I is not equal to j. Okay, and the sum of these two values at the respective indices ai plus aj, and if you sum up these and if you take a remainder with 60, then you must be it should be exactly equal to 0. Like the sum is going to be divisible by 60. We need to return the total number of pairs that is present in this actual array. Okay, this is the mathematical mathematical view for this question. Okay, yes, we need to return the total number of pairs only. Okay, so let's understand this problem with a simple example. Let's pick up this 30, 20, 150, 100 and 40. So let me write down as 30, 20, 150, 100, and the final one is 40. Okay, and we need to return the total number of pairs. Okay, so how we are going to do this problem? So the first approach that strikes in your mind is we need to return the distinct I comma j, right? And what about if you are going to fix the particular index I and check out all those other indices which are not equal to I and find out the sum a plus b, and if it is exactly divisible by 60, it means that the remainder should be 0. Then you are going to pick up this pair. So if you're fixing I for every index of this array, then it will take off O of n time, and O of n into, and if you're checking for every j which are not equal to I, then it will take another time. Like this is the overall complexity. Then you are going to get O of n square time. Okay, if you are checking, if you're doing the basically the brute force approach. Okay, so let's look at the constraints of this problem. It is like 6 into 10 raised to the power 4. So the total amount of time would be like 6 into 10 raised to the power 4 whole square, and it will be around greater than 10 raised to the power 8. So you are going to get a TLE verdict. Although your solution is correct, but you are going to get a TLE verdict. So you need to optimize your solution. So how we are going to do that? Okay, so let's try to understand the modification of this problem, how we are going to modify this problem. Okay, so you need to focus upon the value like a plus b must be divisible by 60. Okay, so this sum, what are the possible values of this sum? The possible values of this sum are 60, 120, 180, and it goes on up to let's say the maximum element is mx. It will be like mx into 2. Let's say there are two maximum element 150 and 150. It will go up to like that, because taking the required sum greater than this value is no need of, we are not going to have any use of for that. Okay, so we are going to discard it. So the sum is going to vary up in this range. Okay, the sum is going to vary in this range. So the one of the possible way is to fix this sum. Okay, so let me first change out the color and explain you. let us say I'm going to fixing this color fixing this value 120. Okay, so I'm saying that a plus b, if it is exactly equal to 120, then our like sum is going to be like divisible by 60, right? So we need to find the total number of pairs whose sum is 120. So this is our modified problem. So in this actual array, we need to find total number of pairs whose sum is 120. Okay, so you can see that it is 100 and it is 20. So there is only one pair right now, I can see. Yeah, it is only one pair. You need to return the only the count. Okay, so there is only one pair whose sum is 120. So it can be 60 also if you focus over that. So it should be like also like the one of the pairs for the 120 sum would be like 20 and 100. Then the other pair would be like you can see 20 and 40. You can see the sum is coming out to be 60. So and can there be like 120? Yeah, it can be 120, like 150 and 30. So there is another pair like 30 and 150. Okay, so basically if you focus over here, it's like the sum like that we require, that is a plus b, is always going to be the multiple of 60, right? So if you are going to fix up 60, fix up 120, fix up 180 and so on up to maximum element, twice of maximum element, and you will check it out what is the total number of pairs whose total number of pairs I comma j, where I is not equal to j, whose sum is exactly equal to this fixed value, either 60, either 120, 180 and so on. Okay, so how we are going to find out that value? Okay, so let's try to understand that. Let me just erase it over here. So there is one popular method you will understand is like let's say you have fixed the value of a plus b. Okay, so a plus b is like 180. Okay, so what you are going to do is you are going to iterate in this array and keep a tracking like keep a hash map that will store the mapping of like a number and its frequency of number of times it has occurred in a hash map. Okay, so what you are going to do, if you are encountering this value 30, it means that one of the value is like, let's say fix it like a is 30. Okay, so 30 plus b must be exactly equal to 180. Okay, so you need to search for all those b whose value is exactly equal to 150, right? So you will just check it out in your hash map whether like the what is the total number of numbers whose frequency is exact, like whose what is the total number of numbers whose value is exactly equal to 150. You are going to check it out. You can see that for now here it is only 30, and if you check it out what is the total number of numbers whose value is exactly equal to 150, you are going to get 0. So you are not going to get any of the pairs right now. Okay, and when you move on to the next number, you will increment, let's say the hash map name is mp, then you will increment the current value, which is 30, by 1. Why you are going to do that? Because for the next of the numbers checking, you need to check it out that whether if you will encounter some value, and if you subtract it like that, like here you can see 30 plus b 180, then b must be equal to 150. Then in might like in future cases, like if you encounter 150, then you need to have the sum 180, right? So you will write down 150 plus b must be exactly equal to 180, then b must be equal to 30. So you need to check in the hash map what is the total number of numbers whose value is exactly equal to 30. Then you are going to say yes, there exists only one number. That's why I have incremented right over here mp of 30 plus equal to 1. So you need to keep track of the numbers, actual numbers that have occurred in the array also. Okay, so this is the one of the way. Okay, so overall what you are going to do is you are going to fix up any sum which is multiple of 60, and you will check it out like that. Okay, so let's head over to the code to understand this in detail. Okay, so yeah, if you look out my submissions, first I've got wrong answer. I don't know why, there are some mistakes. So yeah, let me show up every submissions. Okay, so this was the first one. So what I've done over here is like I've taken a map, okay, and this is the answer as 0, and maximum element I've taken over here, and my required sum would be 60, and it will go up to twice of this maximum element. And every time first I will clear it out, because for every sum we need to keep a new hash map, right? So I will just find out what is the total number of numbers whose value is required sum minus c. Like here, if you focus over it, is if it is sum is 180 and my current value is 150, I need to check in the hash map what is the total number of numbers whose value is 30. Okay, so if we got that frequency, you will increment your answer by that frequency, and every time you need to increment the current value of the array, that is increment the frequency of the current value of the array. Okay, and finally return the answer, you will get the correct answer. Okay, so in the next solution what I've done is like I've just replaced map with unordered map to improve the complexity, but it doesn't satisfy much. Okay, so what is the problem over here? So let me look out my third submissions. Okay, one thing that is also noticeable over here is like you need not to keep all though like you need not to keep a hash map over here, though the very tricky part is like you can do it in O of one time also if you focus one thing that the maximum element, like every value must be within the maximum element, right? So no need to keep track of the hash maps, like it will take a logarithmic time for insertions and deletions. Okay, so you will keep a single vector also or an array of size maximum element, and you will do the same of the operations. And you need to write down one thing also, required sum minus c must be positive and this must be lies within the maximum element, then only you can insert it over here. Okay, and so what is the, like you can still see that complexity is not much good, so another solution is over here. This solution is quite tricky. Let me explain it over here. Okay, so where it is a plus b mod 60, where you need to find total number of pairs over here. So now if you are familiar with modular arithmetic, you can write this as a mod 60 plus b mod 60 whole mod 60. Okay, so you need to find total number of pairs like that. Okay, so it means that you can just take remainder for with 60 for every value of the array element. Okay, so suppose that the current value is like let's say 30. Okay, if the current value is 30, then you will, this value becomes 30 and another value is like 150. Okay, so you will do like that 150 mod 60, which should be like again 30. Okay, and you can see that if you will add up this and take modulus 60, it will be exactly equal to 0. So this is the one of the valid pairs. You can see that 30 plus 150 is like 180 and it is being divisible by 3. Why is it giving the correct answer? Okay, so the another logic is if a mod 60 is some value, okay, so you need to find another value with which you will pair up the sum, like a mod 60 plus this value must be divisible by 60, right? Must be divisible by 60. So how do you find this value? So the very tricky part. So the very tricky part is not much tricky. So you will write down as this another value as 60, it will be like 60 minus this a mod 60. If you are able to find the total number of numbers whose value is this value, okay, or the frequency of numbers whose value is this, then you are going to get the correct answer. Why? Because suppose a mod 60 is like 58, then you need to find those values like 60 minus 58, so it will be 2. So whatever the numbers whose remainder is coming out to be 2 and whatever the numbers whose remainder is coming out to be 58, if you will sum up these two numbers, that these two numbers will always be divisible by 60. Okay, so there is one more tricky part is what about if a number is already divisible, exactly divisible by 60, like if a mod 60 is exactly equal to 0. Okay, in that case you need to search for that number whose remainder is also 60, because then only you are going to get the entire sum being divisible by 60. In that case you need to check it out that this relation will not hold. A mod 60, you need to search for this number, right? And if a mod 60 is 0, then you will get 60, and you need to search for the 60, which is not correct according to this logic. So in that case also you will take another mod over 60 over here. This will give us the correct answer. Okay, so overall what I am going to say is like for each number of this array, you are going to find out the current remainder, which is a mod 60, and for searching part you will search for that number whose value is this one, 60 minus a mod 60 mod 60. Okay, and you will increment your answer with the total number of numbers whose value is this one. Okay, so this is the quite tricky part, and it will take like very less space and less time. So the time complexity for this operation is O of n. Space complexity is only 60, because each time we need those numbers which are strictly less than 60. Okay, like less than 60 or 61, I don't know. Yeah, okay. So this is time dot size, answer 0. I have, for the convenience, I have take the size as 61, and first I find out the current remainder. Then for the searching part, what number we need to search. Okay, so if remainder is some positive number, strictly positive, like greater than 0, then I will search for 60 minus rem, and if it is exactly divisible by 0, then the remainder is 0. Then I need to search for the number 0 as it is. Then I will increment the answer with the frequency of numbers, which is matching with this search variable. Okay, and also I need to increment the current frequency, and also I need to increment the frequency of the current remainder. Okay, finally return the answer. Yeah, this will give you all test cases passed, and like the complexity is far better than the rest of the one. Okay, so if you have any doubts, do let me know in the comment section of the video, and I will ask the viewers to like this video, share this video, and to subscribe to our YouTube channel for latest updates. Thank you for watching this video.